have Laura already with us. She's an associate professor and lead researcher spreading BIM love from a little corner in Spain from University A Coruña. She will tell us about how the BIM will change your mind. Laura, over to you.
Thank you. Well, let me start by hoping that you're coping with the strange times that we're living to the best of your abilities, and wishing that you will stay healthy and safe. So if we would be in Stockholm, I will probably ask you to raise your hand if you've ever heard the sentence that functional programming requires a change of mind, a different mindset. And I will probably, I see some people raising hands, that's awesome. I will probably also ask you if you yourself have used that kind of sentence when exposing someone to functional programming for the first time. And I will also imagine that some of us actually have. I, for one, I'm guilty as charged. But what does it really mean? Because, I mean, sometimes we say things about FP that we all agree about, but it's not immediate for people coming to the community or to the paradigm for the first time what they actually mean. So we see things like, oh yeah, functional programming is all about structuring what you want to do as a function that takes an input and produces the output. And also the output should be the same always when the input is the same. So there's no, you avoid state and your data is immutable, and that makes your functions pure, and you should avoid side effects. And oh, and by the way, your input can be also a function and your output can also be a function, and that's we treat them as first-class citizens, and we use all these terms. And in the end, and we heard this yesterday in some of the talks, this is cool because you're working at a higher level, so what you produce is cleaner, is more clearer, is easier to reason about, and that will make your code more modular, and that will make your code easier to maintain and even easier to test. Oh, and by the way, concurrency will also be easier in this whole setting. And of course, this sounds really, really great. But again, when we're talking at this abstract level without a specific example, it might be really difficult to grasp what it means for a specific solution, or when you're trying to design a specific solution for a problem, no matter if it's simple or complex. So what I wanted to do for this talk was to give one of those examples. So something specific where we can actually visualize what it means to approach something from the BIM perspective, so to speak. So the example, as you heard in the introduction, I am a teacher at the University of A Coruña, and I've been the coordinator of the CS studies for a while now. And one of the responsibilities that I have is project degree assignment. Project degree is what the students have to do right before they are awarded their diploma. So they have to undertake a full project on their own. And some of them have their own ideas about what they can do, but some other students, they just want a project assigned to them. So the faculty will propose a series of possible projects, and there will be some kind of process to assign those projects to the students. From the students' point of view, they have to fulfill certain criteria, academic criteria, of course, because they have to be in the final year. There are certain constraints that will apply there. And then if they fulfill those criteria, then they can request up to 5, and they of course order them by preference. And from the assignment part of the business logic, if you want, each assignment will be bounded to a concentration. So it will require for the student to have passed or be in the process of passing certain subjects. And well, once all those constraints are checked, of course, the assignment goes to whoever has the higher academic performance so far. So that's the problem. And before I came into the role, this was made by hand. So previous coordinators used to have their own Excel spreadsheets and blah, blah. But come on, I've been part of this community for a number of years, I was not in the mood to do this manually, of course. I wanted to implement something to help me with this process. So I wanted to devote just a few seconds to think how you will approach this problem. If you were to design and implement something to help you with this, what will be your approach? How will you solve this problem? And depending on how strong a given paradigm is within your mind, you may immediately fall back to one or of a few options. I've selected 3 aspects to present here, probably the most popular ones. I've tried to convey them in a humorous style. I hope I don't step on any red lines, but if I do so, just please humor me. It was with no evil intention, I promise. So let's start with an imperative approach. If the imperative wall is strong within you, I would argue that you have a mind that I have chosen to describe as the God complex. Why? Well, in an imperative setting, you will probably assume, or you will probably start off from the fact that you see all data. So you know everything about the students, everything about their academic files, everything about their preferences, their marks, anything that you need to do. And that's structured as you will, as it's best suited to you, and is there for you to access at any time that you want. Then I will argue also that you know everything you need to do. You know everything you need to check for each student and each request that they make for a given project, and you know how that comes out. So when a constraint is fulfilled, when it is not fulfilled, everything, every step of the way that you need to take. So the algorithm, you know it, it's in your mind, and it's your mighty will. So you will just analyze the data step by step, following the steps, the algorithm that you know that you want to implement. And that's it. I mean, you're almighty. But what happens if anything fails? I mean, if there's anything wrong with the data, with the steps of the algorithm while you're running it, well, probably the world is yours. So the easiest way is to just to try again, try some fix some things and run it all over again. Okay, let's say that you don't have an imperative mind, but an object-oriented one, or as I've chosen to humorously call it for the purpose of the talk, a despicable mastermind. So in this approach, you say, structuring all data in a way that I have to access it explicitly at any moment that I need it. That's not my sort of flavor. I prefer to see the world as small pockets of data. And these are my minions, my objects. So for a student, I have an object, and that object knows everything about that student. And same for assignments. I have as many objects, and each of them encapsulates the knowledge about one particular object. They don't know about each other. They don't need to know about each other. I know about them. Also, those minions know how to do small things with those pockets of information. So I don't have to do all the work. I can tell them to do small things. So be assigned, or tell me if you fulfill this constraint or not, right? But in the end, you're actually in need of a master anyway. So there's someone who needs to orchestrate what all these small objects are doing in the system. So someone who knows the plan, what's the goal of the system. And while it's slightly easier to imagine that some minions may not comply at some time, but in the end, this sort of thinking, I would argue that you as a master will not be thinking that failure is an option. So you might decide at some point what to do with a minion that is not complying, but you actually trust that your plan is going to succeed. That's part of how you think of the world. So we now come to the functional approach, and that's probably a bit of an overstatement because this is code beam, so it's not the functional as in the broad sense of the word, but the beam approach most specifically. And I've decided to call it the fellowship of the beam. So your system from this point of view is a community of characters, right? Small processes that have their own personality and their own agenda. Each of them knows some information and knows what they can or want to do. And they will do so as the story unfolds, so to say. The funny thing is that some of the characters at some point may turn evil, so you cannot really trust them anymore. Or maybe some of the characters seem to disappear. You may presume they're dead. You cannot reach them any longer. Maybe later on they appear again, but the rest of the characters simply don't wait for that. They just continue with what they can do or they want, or where they want to go without really depending on that, right? That's something that they cope with. And as I say, eventually, because each character is evolving as they need to, the system will, well, the story will unfold and some milestones, hopefully some stable situation will be reached. The great stuff here, from my point of view, is that no one rules them all, right? So a little bit more specifically, of course, I chose the BEAM flavor, the fellowship of the BEAM edition, if you will, for implementing this project degree assignment process. How I design it is that, well, of course, each student is a process, and of course, it's supervised. That's one of the great things about the BEAM, that adding this kind of supervising logic is really easy. We'll come to that in a moment. So each student is a process, and they know a little bit about themselves. Mainly, they know their preferences according to the projects that they are available, and they know how to request, hey, assignment, I want to do you, can I? On the other hand, we also have one process per assignment, and of course, those are supervised as well. So if anything goes wrong, the assignment will be alive again in a little while, and the students will be able to say, hey, I want to do you. Can I? Well, if the assignment is free, we'll say, yes, come on. We can be assigned to each other. Later on, the students say, hey, I want to do you. And say, oh, but I already have a student assigned. What's your mark? If your mark is higher, then let me tell the former students, oh, you cannot be assigned to me anymore, because I have this other candidate with a higher mark. And so the former students will go on and ask the following assignment in their priority list, and so on and so forth. You get the idea. The thing is that in real life, students don't always know everything about themselves. So for instance, when they want to know what's their the overall mark of their student file, or whether they are missing some subject to fulfill certain concentration, well, they go to the administration window, right? So there's some information on the system that is not inherent to you. I mean, you know what your preferences about assignments are, but there are other information you have to gather from other places. So I added a process that represents that administration window. And that will also be like the perfect place to link, to integrate this system with a third-party system that will provide that information that actually exists in real life. And of course, this is also supervised, and it will answer the kind of question that I was saying, right? So what's my mark, and do I fulfill this criteria or not? And finally, because at the end, when the system runs for a while and everything stabilizes and there are no more requests from students and then assignments have been assigned, this has to lead to an official answer, an official decision at the faculty level. I need to be able to explain this. I mean, the process, the system will reach a situation, but I need to say why. So what I did was to add a last process that is kind of a statistical process. It's kind of a logger, but we usually add loggers for us developers or for system administrators to know what's going on. But in this case, this is more visible. It's a first-class process, if you will, because it's part of the outcome of the system to be able to say, hey, there were these requests and this was denied because this other request had a higher mark, so to say, right? So that's like the main population of this solution that I created. If you want to take a little closer look to it, it's on GitLab. That's the QR, and it's a link also. I will share the slides later on. And you will see there are lots of diagrams, sequence diagrams explaining this, and the architecture diagram is, of course, the code is on Elixir. It's a Phoenix application, although the web interface is not yet developed, but you can play with the background, with the backend, sorry, if you will. So the pros and cons of approaching this this is fairly simple, right? I could have implemented it as a God complex approach, if you will, even within the Beam. But doing it in, as Brooklyn was saying yesterday, doing in a way that reflects the intention of the paradigm, in this case, of the context, of the technological context of Elixir and Erlang here, it provides a series of advantages. So this solution is more reliable. I mean, there may be something wrong with a particular student that cannot really recover from some information is missing, some information is corrupt, the same about some assignments, but okay, the rest will still continue. Maybe you cannot really talk to a particular project. Well, after a while you give up and you try with the next one, right? As long as you later on can explain what happens, then this is acceptable. There's also this distribution of responsibilities. So it's great when you have an algorithm that you can all see for yourself, like in the God approach, or that you can clearly steer, like if you're a despicable master. But when you're not really clear about what's going on, or the definitive version, you still here have like all the logic about what a student has to do is concentrated in one place. All the logic about the assignment, the projects, is in a different place. All the logic about monitoring those processes and restarting them if things go wrong are in different places. So those responsibilities are distributed, and you can grow them gradually. I mean, the first version I started was just a student knowing how to ask for a request and assuming that the request will not be assigned to anyone else and that will always reply yes. And then adding different kinds of answers and different possibilities is slowly growing your logic, which is, I will argue, is slightly harder to do when you have to put everything in one block of logic, if you want. And also, it's the great thing that once you have all this in place, execution will be massively parallel. I mean, you don't have to go student by student analyzing what he or she wants and what's their place in what has happened so far. This will organically evolve. Messages will be exchanged, and no matter which order they are sent or received, the final version, the final stable solution will still be the same, right? Which might or might not be the same, but in the case in every system, but it was in this case. Of course, there are also disadvantages, which is there's certain lack of control in distributing that responsibility and allowing that asynchronous execution to be the norm in your system. Because it's really hard to predict when you start things. How long will it take to this for this to get a stable, right? How long will it take? How many messages will have to be exchanged for this to reach the end of the story, right? If you're following a more orchestrated approach, you can say, okay, I'm halfway through the list of students, but here you don't know that. That makes it harder to explain, as I was arguing before. So if you need to make your decision accountable to someone else, then you have to have that in mind, and ideally take it into account in the design of your system, as I did in this case. And then, of course, I was saying before that your logic, the student logic, is very concentrated and isolated from the assignment logic, and that makes those easier to test, to unit test. But testing the whole behavior of the system is slightly harder, and that's where properties and models come into place. And I will refer to you to the keynote of Brooklyn yesterday. Also, she mentioned very interesting things about that. So what you can take home from here, and this is a pun intended, what you can take to the couch later on maybe, is that of course programming paradigms affect the way we think. And the advice here will be to know as many of them as you can, but know them not in a theoretical level, but in a practical level. So what it really means to approach a problem from a certain perspective, and what kind of things it will lead you to do or not, because only that way you will be able to really use them wisely and choose them wisely depending on the problem at hand. And of course you can be a god in the Vim. I mean, you can have different approaches in different programming languages, but it's always easier if you respect what they're trying to do, what they reflect. As again, as Brooklyn was saying in her keynote yesterday, they reflect the intended use. That's what I was trying to write here when I wrote respecting the paradigm is easier. Not everything is a nail, right? So inspect the nail and use the proper hammer, I would say. And for me, I think this is a fairly small example, but it's very illustrative that if you can afford to lose control over what's happening and allow full asynchronism and things to evolve on their own until some stable situation is, some eventual consistency is reached, then the Beam is so powerful for having those small processes that are very proactive and that you can monitor and make reliable in a very easy way. So yeah, that's my take, and this is everything I wanted to tell you about.
Thank you, Laura. This was very interesting. I have a question for you here. So do you explain to students that they are processes, and if so, how do they react?
Oh yes, yeah. We have. Well, I teach 2 different subjects, and this particular project I used with the students that I teach software validation to. So the thing here was with them trying to see how they will approach a system like this from a testing point of view. And the other subject I teach, it has to do with software architecture. So the reason I use the Beam there is because I actually want them to learn about the processes and use them to build things that are really concurrent and really distributed, which is, I would argue that it's harder to do with other platforms. There might be a small learning curve here, but it will allow them to be more powerful. And they do, they actually build amazing projects every term. But I have to admit, I have a little advantage because I usually deal with 3rd and 4th year students, and they already know the Beam, because in the 2nd year they have a concurrency subject, and I don't know if it's like 2, 3, 4 weeks, but they know the Beam, they know how processes behave there, they know the abstractions, not the behaviors maybe, but they know the syntax, so I can really concentrate on set as processes and behaviors and whatnot, which is, well, it's great.
Mm-hmm. Okay, thank you. We have another question from our audience. Do you think there is a place for doing a game development on functional languages or on the Beam?
Game development, I would actually not argue. I know it for a fact. I will tell you about 1 or 2 maybe 2 projects that my students did first term this year, so in autumn. One group, they designed like kind of a dungeon game. So each world, it was kind of a room, no? You could go from one room to the other, and each room was in a different node. So sometimes no rooms will be available. You could actually cross a door and appear in a different node and deal with the processes that were in that room, the treasures that you have to find and that sort of thing. And it was all distributed, and well, you get the idea, I hope. And that was they designed it, so the idea was completely theirs, and the whole process, it was actually great. They did a demo in the classroom. It was great. And different group, did kind of I don't remember this. It's like a board game, but they did the version in Elixir. Oh, sorry, I think I lost you here.
I am here.
And this was like a village of people. So each villager was a process, and it was a user also. So you were assigned a role at the beginning. So you could be a villager, you could be part of the mafia, and so the mob will try to kill villagers, and the villagers will have to try and find out who the mob were. And well, it was also fun. It was a shift game, so you had to wait a little bit in order to take turn and decide what to do, but it was also all on the beam. So yep, I mean, it's also all about your imagination, what you think you can do, what you design you can do, and then the beam here is your tool. It gives you all the concurrency, all what I was saying, right? This asynchronism, and let the system evolve to the next step or the next state in a less predictable but more reliable, more fault tolerant way, if that fits your problem, of course.
Excellent. Thank you, Laura.